All right, welcome boys and girls to our second video lesson in Chapter 2, our lesson on polynomial functions. Here we go. Okay, first of all, let's define a polynomial function. A polynomial function is written right there. Okay, just looking at this, we got the polynomial function is written right here. Okay, it's just a series of terms. Okay, here's our first term, here's our second term, here's our third term, etc. All the way down to our last terms, and we typically have our variable x going in descending order of degree, or the power is going down by 1 each time. Okay, all the way down to 0, and we don't write that x to the 0 term because that just is 1. The degree of the function is the highest power, so in this case it would be m. So the degree of the function is the highest power, so it is going to be m. I'm going to write that right here. And the leading coefficient is the coefficient of the power of the highest term, so that's right here, so that's going to be a. Okay, so looking down here at this function down here, okay, the leading coefficient would be 5, and the degree of the function is 3. As we look at this function, if I were to graph it, 5x to the third plus 2x squared minus 3x plus 7, it would look kind of like a little s here. Here's a little s curve. It's a third power function. The degree of the function is 3. The leading coefficient is positive, which means now it's going to go down on the left side. On the negative side, it's going down, and on the right side, it is going up. Okay, if this were a negative third power function, it would be a mirror image. It would look something like this. It would go down on the left, and it would be positive on the left, and it would go down on the right. And we'll talk more about that in a minute. But just more importantly now, just one more quick little word. This is a relative max right here where our curve takes a maximum, even though it eventually goes back up. This is called a relative max, and this right here, of course, is a relative min. An odd function does not have an absolute max or an absolute min because it does go all the way up to infinity, and it goes down to infinity as well. We will talk about the intermediate value theorem in class. Let's go on. So, looking at this function right here, this red curve, is this an even or an odd function? This is going to be an even function because both ends of the function are doing the same behavior. In other words, this right here and this side right here is both going down, so this is going to be an even function. If I had a function something like this, we'll do this in blue, and then going up, that would be an odd function because on one side it's going down and on the opposite side it's going up. In other words, its end behaviors are going to be different, so that's an odd function. So this is an even function, and it's also negative because it is going down on both sides. This blue function here, it's an odd function because one side goes up and the other side goes down. The end behaviors are different, and this is going to be a positive function, or a p. This is a neg. Okay, a positive function because it goes up on the right and it goes down on the left. The degree of the red function, all you have to do is count the relative maxes and minimums and add 1. And that would be the highest degree that would be the minimum degree that it is. So in other words, we're looking right here. I got 1, 2, 3, 4, 5 relative maxes or mins. So therefore, this is at least a power of 6. While this guy right over here in blue, I got 1, 2, 3, 4, 5, 6. 6 relative maxes or mins, so therefore it's at least a power of 7. Let's go on. Looking at these four right here, I want you guys to decide for yourselves, is it odd or even, pos or neg, and what is the power of that function? Stop the tape and go ahead. Okay, looking at the purple one, this is going to be even, because both end behaviors are the same. They both go down, so therefore it's neg. And this only has one max or min, so therefore it is at least a second power function. It could be as low as 2. The black one here is going to be an odd function because it goes up on the left and down on the right, so it's an odd function, and it's negative because it is going up on the negative side and down on the positive side, and it has 1, 2, 2 relative maxes or mins, so its minimum power is 3. Looking at the red function, it goes up on both sides, so therefore it's an even function. It is positive because, it's going up on both sides. It has 1, 2, 3 maxes or mins, so therefore its minimum power is 4. And the green function is odd because it goes up on the right, down on the left. It is positive because it's going up on the positive side and down on the negative side. It has 1, 2, 3, 4 maxes or mins, so therefore its power is 5. Looking right here, find all zeros of a function. First of all, let's see that this is a quadratic function. We do recognize that. 49 minus x squared is going to have 2 roots. We can factor this thing. So this is going to be 7 minus x, 7 plus x. So therefore, its roots are, we're going to set each of those factors to 0. So 7 minus x is equal to 0, or 7 plus x is equal to 0. So x equals 7, or x equals neg 7. All right, let's look at this second one right here. We can factor this one. So y equals 2x squared minus 14x plus 24. I'm going to start by factoring out a 2. So I have 2 times x squared minus 7x plus 12. I can factor x squared minus 7x plus 12 as 2 times x minus 4 times x minus 3. Once I've done that, set each of these factors to 0. So 2 equals 0, or x minus 4 is equal to 0, or x minus 3 is equal to 0. Well, guess what? Hello, 2 does not equal 0. X equals 4, or x equals 3. You guys try these two. The first one you can factor. The second one you're going to have to whip out your graphing calc and use your graphing calc to come up with those roots using the root feature. Go ahead. Okay, you should have found for the first one you can factor that. You can first of all pull out an x from each of those terms. So you pull the x out in front. Okay, we're going to pull the x out in front right here. And then we have two factors, x minus 2 and x minus 3. So therefore, x is equal to 0, 2, or 3. In the second one, you have to use your calculator here. We don't know any other way yet. Okay, but if you graph this thing, you would find that on the graph will only pass through the x-axis once. In fact, your graph's going to look something like this, where we have the first bump down here below the x-axis. Okay, but we have a root right here. And that was about 6.75-ish, and you should at this point know how to find that using your calculator. Let's move on to our last slide. Write a polynomial function that has the given roots. We're just going to go backwards here now. So what we're going to do, if we have a polynomial function with the given roots, in this case it's 6 and 3, I can say y is equal to x minus 6. That was the factor that takes care of a root of 6 and a factor of x minus 3. That's for the root of 3. So y is equal to, I'm going to FOIL out now, x squared minus 3x minus 6x minus 9x plus 18. The second one here, I have roots of negative 2. So if I have a root of negative 2, I'm going to have a factor of x plus 2. I have a root of 5, so I'm going to factor of x minus 5. And I have a root of 0, so I have a factor of x minus 0. So I'm going to FOIL out on the left first. I'm going to have x squared minus 3x minus 10. and then I'm going to multiply each of those terms by x. So as I FOIL here, okay, I have x squared minus 5x plus 2x minus 3x minus 10. And then I take that whole thing and I multiply it by x. So I'm going to have x to the third minus 3x squared minus 10x. Okay, I'm going to pause for a quick second here and erase. Oh, well, I thought I was going to erase, but I can't. But just looking at this last one, we're going to FOIL out with our 3 given roots. We have, it helps to have a pen here. Hold on one second, sorry. We're going to have a root of 1, so we have a factor of x minus 1. I have a root of negative 2, so I have a factor of x plus 2. And I have a root of 3, so I have a factor of x minus 3. You need to triple FOIL that out and write it then as a y equals the first 8 people who email me that correct polynomial multiplied out with a triple FOIL will receive a bonus point on our next test and or quiz. Have a great weekend, folks. We'll see you soon.